Right, section 2 is about defining our quadrilaterals. We need to go over some definitions of each type or each kind of quadrilateral that we have. Now the first thing I want you to add into your definitions is this word diagonal. That's a segment connecting non-consecutive vertices. What I mean by non-consecutive, that means vertices that aren't right next to each other. And vertices, remember, is just like the corners. So in this figure, A going over here to C, that would be called the diagonal, because A is usually, it's right next to B and it's next to D over here. A is not right next to C, so if I connect those, that is what's called a diagonal. Okay, so whenever we're talking about diagonals, that's what we're getting at. So if we look at some of our actual shapes then, a trapezoid. A trapezoid is a quadrilateral with only one pair of parallel sides. So quadrilateral means four-sided figure. One pair of parallel sides means the only thing we know for sure is that this is parallel to this. If they tell you that figure A, B, C, D is a trapezoid, this is all you can figure out. The only information is AB is parallel to DC. So let's look at what an isosceles trapezoid would look like. Okay, this is a specific kind of trapezoid that has the non-parallel sides being congruent. So because it's a trapezoid, it's right in the name, trapezoid right here, we know that there's one pair of parallel lines, or parallel sides. That's right here. So we can say if X or W, X, Y, Z is a trapezoid, then XY is parallel to WZ. Okay, that's this information. And because we want the non-parallel sides being congruent, we can also say that X or WX equals YZ. This one is congruent to this one. These are the exact same length. Okay. Now, piece of information with that, if these are going to be the same length as each other, and they're in between these two parallel sides, that means this angle is the same as this angle. Okay. The fact that it's a isosceles trapezoid makes the base angles congruent. So we'd be able to say this angle is the same as this angle. Now by same side interior angles, if this one is parallel to this one, then this one here, because these two are going to be supplementary, and this is the same as that one, so this one also has to be the same exact angle. So because we know if they told you that WXYZ is an isosceles trapezoid, we would have all of this information in black so far. But we also know we can take a diagonal. I want to make a diagonal from W to Y and from X to Z. Because this is specifically an isosceles trapezoid, these diagonals are exactly the same length. If I were to pull these away, these two are exactly the same length as each other. We can fit them right back into their spots here. So we would say these diagonals, WY and XZ, are equal to each other. Okay, so isosceles trapezoid gives us a fair amount of information. Let's keep going though. We've got a kite, which is a quadrilateral that has two pairs of consecutive equal sides. Quadrilateral meaning has four sides. That's really the only information it gives us. Because it's a kite, we know something a little more. Two pairs of consecutive equal sides. Consecutive means they're right next to each other. So this one is right next to this one. Those ones are going to be equal. So we can say HI equals IJ. This side, HK, is right next to KJ. So if these two are equal to each other and these two are equal to each other, then we know for sure it's a kite. When this happens, this makes these angles, this one and this one, have to be the same degrees or the same measure as each other. Okay, there's no way to draw a kite that these would be different angles. So we know if HIJK is a kite, then I know that H to I is equal to I to J, HK equals JK, and angle H equals angle J. Now again, the last piece of information that we can figure out is something about these diagonals. If I go from here to here, here to here, so we make the two diagonals, HJ and IK. Oops, it says congruent. They are not congruent, they are perpendicular. H to J is perpendicular to IK. If you want, you could draw in, this is a right angle that it makes right here. So HJ is perpendicular to KI. So that's all the information that we would figure out just by knowing it's a kite. Let's keep going. Parallelogram is a quadrilateral that has two pairs of parallel sides. Okay, so a trapezoid specifically only had the one parallel side. Parallelogram has to have two pairs. So we'd say this is parallel to this one. I'm going to use two arrows to say these two are parallel to each other. Okay, so the things that we know is that LM is parallel to ON and LO is parallel to MN. Now this makes, if these two are parallel, the only way for that to work is if the opposite sides are congruent and the opposite angles would have to be congruent. Okay, so again, by them telling us that this is a parallelogram, we can figure out this side has to be congruent to this side. This side has to be congruent to this side. So we can add in some information. LM equals ON. LO equals MN. We also know, we'll do this one in blue, opposite angles, O equals M. Angle O equals angle M. Angle N, this piece here, equals angle L. Okay, and the last thing we need to look at is see if their diagonals do anything. If I draw a diagonal here to here and here to here, we don't necessarily know if they are the same exact length as each other. Sometimes they might be, but not always. We're going to call this spot where they cross each other V. We know that these diagonals will bisect each other. So I'm going to use 3 dashes for this one. O to V is the same as M to V. I'm going to use a little circle for this one. L to V is the same as N to V. Okay, these lines bisect each other, making this length from here to here the same as this length, and this length, O to V, the same as M to V. Or you can kind of say this spot V is the midpoint of both L to N, and it's the midpoint of O to M. So that's all the information that we'd find out if they told us LMNO is a parallelogram. Then we can say for sure all of this information, all of this stuff, has to be true. Rectangle. A rectangle is a specific kind of parallelogram that has each interior angle being a right angle. So everything that was true from this parallelogram, all of this information, is also true on a rectangle. Okay. Another piece of information that would tell us is that the diagonals are congruent to each other. They're exactly the same length. So not only do they, let's go back, not only do they bisect each other because it's a parallelogram, they're also congruent to each other. So let's draw in some of the things that this tells us. It's a parallelogram, so that is parallel to that. That is parallel to that. This side is congruent to this side. This side is congruent to this side. They're the same exact lengths. Use this color. All of these are going to be right angles, not because it's a parallelogram, but specifically because it's a rectangle. It's a specific kind of parallelogram, one that has all of these ones being right angles. So we can say AB parallel to DC, AD parallel to BC, AB equals DC, AD equals BC, angle A equals angle B equals angle C equals angle D equals 90 degrees. And if we draw in the diagonals real quick here, D to B and C over here to A, like before, we're going to call that spot in the middle, give it that a point and call it point O. Then A to C, this diagonal, is the same length as D to B, so all the way across, plus all of these pieces. I'm going to use the 3 dashes. This one is just as big as this one, it's just as big as this one, it's just as big as this one. Okay, so they make A lot of information given here just by us knowing, just by them saying, oh, this A, B, C, D, this figure is a rectangle, then we can say for sure all of this information has to be true. Okay, we don't have to prove it. We can just say that's the definition of a rectangle. Moving on then, rhombus. A rhombus is a specific kind of parallelogram. Again, just like a rectangle, because it's a parallelogram, all of this information has to be true about it. So it's a specific kind of parallelogram that has all sides being congruent to each other. So let's check this out again. Parallel means, or parallelogram means that side is parallel to that one. This is parallel to this. Because it's specifically a rhombus kind of a parallelogram, all of these sides are congruent to each other. They're all the exact same length. Because it's a parallelogram, this angle equals this angle, and this angle equals this angle right here. Okay, so that would be all the information in black. We can figure all that out. Plus, if we draw in the diagonals, going from Q to S and R to T. Okay, and then again, like before, we're going to label that middle point a certain spot. I'm going to call it P. We would say because these diagonals bisect each other, because it's a parallelogram, I can say that R to P has to be the same as T to P. I can say that Q to P has to be the same length as P to S, and these diagonals are perpendicular to each other. So I can put a right angle right here. Okay, all of these have to have or be right angles because these two lines are perpendicular. Anytime that it's a rhombus, all of this information is true. Okay, you can write all of these pieces down for any rhombus. The last thing we need to look over is a square. A square is a specific kind of parallelogram. So again, everything true about a parallelogram is true about a square. It's a very specific kind of parallelogram that is both a rectangle and a rhombus. So everything true about a rectangle is true for a square. All of this kind of information. So it should look something like this. Also, everything true for a rhombus. All of this information would also be true for a square. Okay. Another thing to note, a square would be a regular quadrilateral. If we talk about a regular triangle, that's an equilateral triangle. So all the sides and all the angles are congruent. Same thing, a regular quadrilateral means that we're talking about a square. So because it's a parallelogram, this one and this one have to be parallel. Oops, and I'm going to write in our spots. This is A, this is B, this is C, this is D. AB would be parallel to DC, BC is parallel to AD, AB is the same length as BC, same as CD, same as DA. Okay, that's because it's technically it's still a rhombus, so all the sides have to be the same. It's also technically a rectangle, so all of these have to be the same. They have to be 90. So that's true. And if that wasn't enough, we can go like this, make our diagonals A to C and D to B. We know that AC is congruent to, or is just as big as, D to B. So these are equal in measure. They're just the same length. If I labeled that spot right in the middle where they cross, I'm going to call it S. A to S, to draw the 3 bars, is the same as C to S. Okay, that's true for any parallelogram. These two bisect each other, but specifically because this one is square, I can say that all of these kind of half pieces are the same as each other. Also, specifically because this is a square, these two are going to make a right angle. Here, 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 and here. These are perpendicular to each other. So if we said A, B, C, D was a square, you could get all of this information from that. All of that has to be true. Okay? So that'll be it for this video. We're going to use all of that information to go over some examples in our next video.